Hello everyone, I'm Frank, and this is the hopefully final installment of the solve of Sudokuvania, Digits of Despair. It's been a long time, and we are on the final grid, which is kind of exciting. And I'm armed with my brain juice, so hopefully we can do this in just one episode. We shall see. Anyways, let's get to the puzzle. Okay, so last we solved the Halls of Illusion, and we filled out the entire grid, so we have solved for the grid. Now we have to figure out do we have any other extra rule sets? Not that I can see. Okay, so we have the hall. We have, okay, grid 9, designated by the Golden Temple. The dazzling wealth on display in the castle's highest tower puts the rest of it to shame. Who knew Sudoku could be so lucrative? I don't know if it is, but interestingly enough, we have, okay, so we have these digits are the, whatchamacallit, the library ones, which index where that is, right? So if this were this indexes where the 1 is. This indexes where a 2 is. This in the row. So the remaining digits in this box are 2, 5, 6, 8, and 9, right? It cannot be 2 because that would indicate that those are 1 in the second column, which there is not. So this cannot be 2. This says where the 3 is. None of these can be 2. Actually, this has to be a 2 here, because this is saying where the 3 has to be, and then we know the 3 in row 9 has to be in column 2. So this is a 2 here, which means the rest of the box cannot contain 2. Okay, we have a dark, which means it's smaller than the surrounding orthogonally adjacent cells. So this is smaller than 3 digits. So it has to be up to 6. 1, 2, 3, 4, 5, 6. These digits are on a German whisper line. So we have 1 low and 1 high. One of these is from 5 to 6, the other's from 8 to 9. Right? So we have to have 3 here, and we have to have 3 one of these spots. Do we have any additional rules? No. Okay. So 3 has to be one of these because the 3 has to be in one of those spots. The 2 here has to be either here or here. The 1 has to be either here or here. So only one of these. Okay. So the 1 is in 5, 6, 8, and 9. The 2 is in 5, 6, 8, or 9. The 3 is in 5, 6, 8, or 9. Well, only one of them can be in 8 or 9. That means the other 2 have to be in 5, 6. Which means 5 and 6 have to be one of these 3 cells. The other is 8 and 9, which means this has to be 8 and 9. Since this is 8 and 9, that means the 3 cannot be here. The 3 has to be one of these, so this cannot be 3. And this must be a 5 or 6, because the 3 must be in the 5 or the 6 area. Therefore, and this cannot be 5 or 6. Actually, we know this has to be 1, 2, or 3. This is 1, 2, or 3, because the only places for 1, 2, and 3 have to be here. So this is 1, 2 with 6, 7, 8, and 9. You cannot have 5 or 6. So it's 1, 2 with 7, 8, or 9 here. We're not sure. And then 4 has to be one of these two, right? Because we know there has to be a low here, and that's 1 or 2, but there cannot be two lows next to each other on a German whisper line. Therefore, these are the remaining 1, 2, and 3, and we know 3 has to be one of those. 4 is one of these. We have 4 with 7, 8, and 9 remaining here. So this is 4, 7, 8, 9. Okay, do we have anything else? This is smaller than this. Okay, so this has to be smaller than that. This cannot be 3. Ah, where is the 3? In row 7. It must be here. So this is not 3. This has to be a 3. Oh, interesting. These are all gold marks. This is smaller than this. Okay. This is probably where the gold coin stuff becomes more important. One of these is 1, the other one's going to be 2. So if we have another gold coin anywhere, okay, that's a lot of gold coins we have to take into account. Okay. I figured this was going to happen at the end, right? Because there was a gold coin issue, right? Let's count up how many we have. Okay. And we're going to mark it here, right? So we're going to have... I don't want to unexpose any fog. So 1, 2, 3, 4, 5, 6, 8, and 9. We don't have any in grid 0. We do have some in grid 1. So in grid 1, we have a 6 and a 7 and a 9. All right, 6, 7, 9. In grid 2, we have, I think, 5. This is grid 2, right? Grid 2, we have 5, 8, 9. So we have 6, 7, 9. We have a 9 here. We have a 5 here. We have an 8 here. So we have 6, 7, 9 in grid 1. Ugh. Maybe I should have put it lower. Yeah, let's put it lower. Closer to the, It would have been nice to be able to, anyways. 9, 8, 7, 6, 5, 4, 3, 2, and 1. We have grid 1. So we have grid 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can't see them, sorry, because they'd have to be zoomed in. We have, again, 5, what is it? 5, 6, and 9 in grid 1. No, 6, 7, 9 grid 1. 5, 8, 9 in grid 2. So 6, we had 6, 7, 9 in grid 1. We have 5, 8, 9 in grid 2. In grid 3, wait, is this grid 3? This factory is 3, right? Yep. In grid 3, we have 4, 8, and 9. So we have 4, 8, 9. Grid 4 is over here. We have 7, 8, 9 in grid 4. Yeah. Grid 4, we have 7, 8, and 9. Grid 5 is here, right? It's a library. Yep. So grid 5, we have 6, 8, and 9. So far, it's been 3 coins each. 6, 8, and 9. Do we have... grid 6 is maintenance. We have 6, 7... And I don't see anything else. 6, 7, and 8. We have a battery thing here. What is that battery? Weird. Okay. We have 6, 7, and 8 in the battery. Or, sorry, in the maintenance. So we do not have a 9 there. Interesting. Have to reset. 6, 7, 8 in... maintenance. So we have 6, 7, and 8 in maintenance. And then we have nothing in the Philomena portal, which is grid X. And then we have in grid 7, what do we have? I think it's 5, 7, and 9. Yeah, we have 5, 7, and 9. So there's been... okay, so how many do we have? We still don't have... we haven't gotten... we haven't filled out 8 yet. 8... I don't think there was any coins actually in 8. Yeah, there are no coins in 8. Okay. So how many total do we have then so far? There was nothing in 8. Ooh, I did not want to do that. And then go here. Okay, so total we have 1 and 4. We have 2 and 5, 3 and 6, 4 and 7, 4 and 8, and 1, 2, 3, 4, 5, 6, 7. And no, 6 and 9. 1, 2, 3, 4, 5, 6. So we need 3 more 9s. So this is 3 more 9s. So this is all probably a 9. We need 3 more 9s. We need 4 more 8s. We need 3 more 7s. We need 3 more 6s, 3 more 5s, 3 more 4s, 3 more 3s, 2 more 2s, and 1 1. We already have one of the 1s already taken into account. So for this, we need 1, 2, 3, 3, 3, 3, 3, 4, and 3 here. Okay. That doesn't increase anymore. This is the max. Okay. Let's zoom this way. Okay, so we need one more 1. So we have one of these is going to be 1, and one of these is 2. So this, we now have, we have 1 taken into account, 1, 2 taken into account, 1, 8, or 9 taken into account, we're not sure which, and 1, 5, 6, 8, 9 taken into account. This is smaller than 3, and we already have a 1, so this must be 2 then. And that must be the last 2. So this is 2 now. We have 2, 2. Because this has to be smaller than the 3. This is 2. We have money bags. Interesting. So 9 cannot be any of these. Because they're all smaller than another digit. So 9 is not one of these. Okay, let's take a look and see if we have an additional rule set for the money bags. Oh, that was not smart. We do not have anything for the money bags. Okay. Okay, so this is 2. We cannot have a 1 anywhere here, right? If these were one of these is 1, one of these is 2. But these are all gold coins now. And we already have 1, 1, right? So 1 cannot be any of these. 1 cannot be next to or adjacent to any of these. Therefore, this is 1, which makes this a 2. This cannot be 2 anymore. The 2 means that this has to be a 5. So this is 5, this is 6, which makes this not 5 or 6. This is 8 or 9. So we have 1 8 and 1 9 now. We have 1 of each. This is 1 with 7, 8, or 9. If this is 1, that would mean this is 8. So this can never be 8 here. If this is 1, that means this is 9, so this can never be 9 here. These two digits cannot contain a 1 or 2, so this is at least 7, 8, or 9. This is at least 3, 4 with 6. None of these can be 7, 8, or 9. Sorry, it cannot be 1 or 2. So this is 3 or 4, and it has to be with the other 8 or 9. Because 3 can only be with 8 and 9. 4 can only be with 8 or 9. 4 can only be with 9, actually. And there must be a difference of 5 between them. This is less than at least 3 other unique digits. So this is at most 6, but it can't be 6. Because of that 6. It can't be 1, can't be 2. This is 3, 4, 5 here. This has to be less than that. So this is at least 4. We have 4 through 9 there. This is 1, this is 2. 3 cannot be here. Where is 1 in column 3? This has to be smaller than these two. So it cannot be 1. Therefore, this is a 1. This is a 1. Okay. The remaining digits in column 3 must be 4, 5, 7, 8. It cannot be 8, 9 because one of the 8 and 9 is here. So it's 4, 5, or 7 here. This is 4, 5, or 7. This can never be 5 then. If this is 5, that would force this to be 4 and 7. So this is 3 or 4. One of these is 3 or 4. One of these is 3 or 4. So we have one each of 3 or 4. One of these is 3 or 4. This is the 3 or 4 also. We have a 3, 4 pair here. One of these is 3 or 4. This is 3 or 4. So it cannot have 3 or 4 in the remaining column. So this is a 5, 7 pair here. So we have 1, 3, and 1, 4 guaranteed. We have 1, 8. We have another 8 and 9, but we don't know which one. This cannot be 1 or 2. It's less than only one other digit right now, though. So we have all the 2s we need. So this is done. We have all the 1s. This is done. 1 from 7, 8, or 9 is here. Where is 1 in column 6? Can't be any of the coins. Can't be the 3, obviously. Can't be in column. Actually, where is it in box 8? Can't be here, because this must be a 1. Can't be here, can't be here, can't be in any of the coins, therefore it must be here. So this is 1. This has to be a 5, 6, 7, 8, and 9 set. Two cannot be in the coins. So 2 has to be one of these 2 cells, which means 2 must be one of these 3 here. 1 cannot be coin, cannot be here, here, or here, so it must be here. So this is 1, which means one of these is a 1 also. 1 is one of these 2. 1 cannot be here, 1 cannot be any of these, but 1 could be any of these 3. Okay. What about 2? 2 has to be one of these 3. 3 is one of those 2. Two is one of these 3 also. This is smaller than 2 unique digits, so it's 7 at most. This is less than 2 unique digits, so it's 7 at most. But the problem is, if it were 7, this would be greater than that. So this can't be 7 either. This is 3, 4, 5, 6, because if this is 7, it would be, that would force that to be 5, and therefore this would be greater than that, which is not allowed. So 3, 4, 5, 6, this is less than 2 digits. So we have 3 through 7 here, but this can't be 3 because of that 3. This must be less than that, so this has to be 5, 6, 7, 8, and 9. This is less than that, so it could be, it can't be 2 because you can't have a 2 in here. 3 cannot be any of these, right? If this is 3, therefore this would be greater than that, which is not allowed because a shadow space must be smaller than all orthogonally adjacent non-shadow spaces. But, okay, if this were 4, that doesn't work. This can't be 4 either because one of these would be bigger. So this is at least 5. This is at least 5. This could be a 4 here. So we don't know about that one. This is smaller than 2 unique digits, so this is 7 at most. This has to be 4 through 9 because it has to be greater than that. This is smaller than 2 digits, so this is also 3 through 7. This has to be 4 through 9 here. Okay. So we know there's a 3 in one of these 2 cells. So this, okay, so this is a 3 here as one of those, and then there must be a 3 in one of these 2 cells in column 5, because this cannot be greater than that. Sorry, this has to be greater than that, and this one could be a 3. So we have 2 3s accounted for now. Okay. One of these is a 9. One of these has to be an 8 then also. So we have 2 3s already accounted for. One is one of these 2. One is one of these 2. This cannot be 4. If this is 4, that forces this to be 3, and this would be greater than 4. So this is 5 through 9 at least. What other 2s are missing? I don't think we're missing that many. Yeah, I'm wondering if I should double check the coins, because just to make sure. Because miscounting that could be problematic. Let's just continue. We do know we don't have any 1s or 2s, and those are already accounted for in grid 9. Remaining digits in box 4 are 2, 3, 4, 6, 8, 9. But 2 cannot be here. 4 cannot be here. These can't be 2. This can't be 4. It's already there. This can't be 3. So that doesn't really tell us much. Remaining of these is 4, 5, 6, 8, 9. Twos here, 2s here. We need, okay, so how many coins do we have? We have 2 here. These are already, 2 out of these 3 are accounted for, so that's a third. 1 of these is accounted for, so that's 4. We have 5, 6, 7. 1 of these is not accounted for. That's 8, 9, 10, 11. Hold on. So again, both of these are accounted for, so that's fine. This is accounted for, and the 3 or 4 is also accounted for. So the other 1 is not accounted for. That's 1. We have 2 and 3 here. 1 of these is accounted for, so the other one's not. 4. This is obviously accounted for. 5, 6, 7, 8, 9. 1 of these is accounted for, but the other is not. 10, 11, 12, 13, 14. I don't think that's enough. We have 14 that we need to account for. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, that's difference of, how many did I say? 14? Was it 14 or 12? I think it was 12. That would be a difference of 5 still. Okay, so again, these 2 are accounted for. Okay, actually, let's just, we can remove essentially all of these. So we can just count the numbers that are not 1 and 2. 1 of these is 1. Both of these 2s are gone. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19. Whereas we have 3 times 6, which is 18 plus 4, which is 22. So we have 3 other coins we have to find. Interesting. Let's say this was a 3. If this was 3, we know one of these is 3, one of these 3 has to be 3, therefore this would be 4, 5, which would force that to be 9. Okay, that seems reasonable. We have 4, 5, and 9. We have a 3. We have another 3. We have one more 3. So all the 3s are taken care of. We have a 4 now. We have 1, 4 here. Three cannot be... Oh, 3 could be here, though. We have 3 more... We should have 3 more coins left. But... Unfortunately, this doesn't seem to limit things here. Interesting. So if this were 4, this is obviously 3. That would mean with this 3 and this 3, there are no more 3s and coins. So 4 would be here, which means 4 cannot be here. 4 would then have to be a coin here. So we have a coin for 4 here, a coin for 4 here, and this would be 4, 5. So that would be 3 4s already taken into account. You'd have a 5. Oh, that's interesting. If this is 4, that forces this to be 3. Am I missing something? I don't think so, unfortunately. Actually, we should already have the 2s marked off, right, for the coins? Let's take a look and see if we do. We should have the 2s marked off. And while okay, so the 2s are not marked off right now. Interesting. Why are the 2s not marked off? Shouldn't it mark it off once you get the 2s? I don't know. We know that's definitely a 1, so this has to be 2 because it has to be less than that. Okay, let's count the coins again just to make sure. There are no coins here. So we have, again, 6, 7, 9 here. We have 5, 8, 9 here. Where's the 5? This is 5, this is 8, this is 9. In 3, we have 4, 8, 9. In this one, we have 6, 7, 8. There are no 9s. We have a battery. I don't know what that does. Okay, it takes it to that area. So let's... This, I think, was just 6, 8, 9 in the library. Let's zoom out this way. Let's zoom in this way. This was 7, 8, and 9 here. There was nothing in the Hall of Illusions, if I remember correctly. This one's hard to... Okay. 5, 7, 9 in the Elsewhere. And then we had nothing in the Hall of Illusions, right? So far it's 3 everywhere, except for the Hall of Illusions. Yeah, there's nothing in the Hall of Illusions. Oh, that's weird. Okay. That's not helpful. I guess let's go this way? Yeah. And then go this way. Okay, we're back to here. What logic has to be here? Hmm. Hmm. What are the money bag things? Hmm. Okay. We have a decent amount of 1s, but that doesn't help us too much. The problem is we don't know if this is shaded or not, so that doesn't help us. This is next to 2 unique digits. This is next to 2. This is next to 2. This is a 2, obviously. Oh, this can't be 2. If this were 2, this would force this to be less than it, which is not possible. So this cannot be 2. Therefore, in box 4, the 2 has to be here. Nice. Okay, this is an arrow. That's interesting. I don't know how that works. 2 has to be one of these 3 digits. We have an additional coin. So that means we have, I think, 2 left. 2 additional coins left, right? We needed 22. We had 19, right? Because discounting this 1 and these 2, there are, okay, actually, let's just say count the total, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We needed 3 times 6, which is 18, plus 4, which is 22, plus 20, 25. And did we have 22 again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. This is 23. So we needed 25. We have 23 so far. Oh, interesting. This must be a 3 or a 4 here, right? And one of these is 3 out of 4. This cannot be 1, 2. It's either 2, 4, 4, 8, or it's 3, 6. So this is 2, 4, 3, 6, or 4, 8. Either way, this must be a 3 or a 4 here. That eliminates 1, 2, 3, 4 in the remaining box, except for this could be 2. So this cannot be 3. So this is not 3 and 6. This has to be a 4 here. Since 4 has to be here, this cannot be a 4. So this must be 3 with 8 or 9. This is a 4 then. We know this cannot be 4 here. This can't be 3 anymore because of that 3, so this must be a 4 here, which means this can no longer be 4. 4 cannot be any of these. So 3 has to be one of these 2. We're not sure which. We have 4 here with 2 or 8. This could be a 2. No, 1, 3, 5, or 7. So it's 4, 6, 8, and 9, but it cannot be 4. Therefore, it's 2 with 6, 8, or 9 here. This can't be 1, 2, 3, or 4, so this is 5, 6, 7, 8, and 9. I'm not sure what this thermo with this arrow means. It cannot be 1, 2, 3, or 4 either. This is 5 through 9. This is 5 through 9. So we know 3 has to be one of these 2 also. This is 4. We have 5 and 7. So both 5 and 7 have to be 2 out of these 3. Interesting. Okay. 4 is less than 5 and 7. That's true. Ah, If this is 4, that would force this to be a 3. We know there has to be a 3 in one of these cells. There has to be a 3 in one of these coins. So that's 3 threes in coins, which means this cannot be a 3 in a coin. It would have to be 4, 5. But because there's a 4 here, that eliminates 4 here, which would force that to be 4. And therefore, this could not contain a 4 here. So this can never be 4, because that would force this to be 3. Interesting. Hmm. Yeah, I don't understand this thing here. But maybe it'll clear out once we have more information. We need 2 more coins. Not sure what those are. If this is 7, this is 8, 9, 8, 9. This would be 3. This would then be 6. Hmm. Interestingly, if that's a 3, that has all the 3s then. Right? So if this is 3, that would force this to be 3. This could not be a 3, therefore this would have to be 3. And this would not be 3, this would be 4, 5, and 9. Hmm. Hmm. Okay, so say this was a 3. That would guarantee that's a 3 here, which would mean that could not be a 3. This would have to be 3, this would have to be 3, and this could not be a 3. Ah, okay, I see it. If this is a 3, that means we know a 3 is here in row 1 and 2 for box 1. We know there's a 3 in rows 1 and 2 for box 3. Therefore, there cannot be a 3 in the remaining of rows 1 and 2, which would force a 3 to be here. Therefore, there would be a 3 here, a 3 here, and a 3 here for all 3 coins. But a 3 being here, we know there's a 3 in rows 8 and 9 for box 9, and there would be a 3 in box 3 with rows 8 and 9. Therefore, there cannot be a 3 in the remaining of rows 8 and 9, or columns 8 and 9, pardon me. Those are all columns 8 and 9. So that would eliminate 3 here. So this would have to be a 3, and we would have 4 3s in coins, which is not allowed. Therefore, this cannot be a 3. This has to be 4, 5, and this is a 9. There's another coin here. One of these is a coin, and therefore the 3 is matched fully. This is a 4-5 pair, which means 4 has to be one of these 3 digits because we have a 4 here in rows 1 and 2, another 4 in rows 1 and 2. That eliminates 4 in the rest of the rows. Shoot, that's not enough coins. Right? That's 24 coins. Did we miss a coin somewhere? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We're missing a coin somewhere. This can no longer be 3 because one of these is a 3. One of these is a 3. This cannot be 3. Therefore, this must be a 3 here. So since this is 3, this cannot be 3. So this is 3. One of these is a 3. One of these is a 3. This cannot be 3 because it's on a coin. So this is the only place for it. So this is 3, which means this can't be 3 here. This can no longer be a 4. So this is a 3 here. 4 has to be one of these 2. So we've got all 3 3s now accounted for. We're missing a coin, though. This is 4 and 5. One of these is 3. 4 has to be one of these 3. This can no longer be 2 because 3 has to be smaller than this digit. So 2 is one of these 2. We have a 4. We have another 4 here. One of these is 4, so that's 3 4s. This is smaller than these, so this cannot be 5. This cannot be 1 or 2, because if it were 1 or 2, it would be greater, or sorry, it would be smaller than either of these. Therefore, this is a 1 2 pair here. This cannot be 4 because it has to be greater than this digit. So this is 6 7 8 9. Where is the 4 in row 4? It has to be here. So this is 4, which means this cannot be 4. These cannot be 4 either. This is 4. This is must be greater than that cell. So this is 5 through 9. We do not have a boss here. Where is the boss? Weird. Okay, I don't... Or does this count as the boss? Do these money bags count as the boss? I don't even know. Hopefully that would be the... Well, I don't know. But the last coin. So this 3 means this can't be 3. Sorry, this can't be 8. This can't be 9. This has to be 8, which forces this to be 9. Which means 1 has to be in the 9th column. This is 1. This cannot be 1 here. There cannot be a 9 in the rest of this column. This can't be 8. This is a 3 and 9 pair here, which eliminates 3 and 9 from the rest of the box. So we have 2 9s now. We have a 3, we have a 4. We have 3 4s. We have a 4 here, a 4 here, and a 4 here. So that's 3 4s so far. Actually, that's all of them that we need. So we have all the 4s accounted for also. We have a 5 accounted for here. This can no longer be 9. This is 6 or 8. 6, 8, or 9 is here. We have 1 8, 2 9s. We have not got any collectible coins yet. Hey, keep your eyes open for any collectible coins. You hear? There are only 45 ever made, right? Each one from 1 through 9. Whoops. Let's go this way. Ooh. That's not right. Okay. Oh, there's there's more stuff. Anyways. Where's the boss here? Uh, okay. We don't have this final rule here. Interesting. Okay. We have a 5. This cannot be 4. So this is 5 or 6. Must if this were so this cannot be 5 in either of these spots. This one of these could be 3. Oh, we have all the 4s, so this can never be 4. Where is the 4 in row 3? Can't be any of these because of the 4-5 pair. Can't be any of these because one of these must be 4 to be 2-4 ratio to 1-2 ratio here. So this must be a 4, which forces this to be 3. So this cannot be 3 here because this has to be smaller than that. This cannot be 4, therefore this is a 4 here. This cannot be 4 either. Where's the 4 in column 5? Can't be here because of this 4. Can't be any of these because of that 4. Can't be any of these because of this 4. It must be here. So this is 4. We have 7, 8, 7, 8. Where is 3? 3 must be one of these 2 digits. Okay, so this is a 1, which means this cannot be 1. This can't be 1 either. This is 2, this is 1. This can't be 2 then. That forces this to be the 2 in box 9. Where is a 2 in column 8? It cannot be either of these, so it must be here. So this is a 2, which means this cannot be 2, which means this must be specifically a 2-4 pair. 9 has to be one of these 2. This is 4. That leaves 5 cannot be here. 9 cannot be here. This is 6, 7, and 8. 6, 7, and 8 here. If this is 5, this has to be 7. If this is 6, this also has to be 7. So either way, this is 7, this is 5. Therefore, this cannot be 5. Where is the 5 in box 5? It cannot be either of these. Why is that the case? Why? Can't this be 5? No, because it has to be greater than that. So this has to be greater than that. These can't be 5. This has to be greater than that, which is 5, 6, or 7. So this can't be 5, and this can't be 5 because it has to be greater than that. Therefore, this is a 5 here. This can no longer be 5. The remaining digits are 2, 6, 7, 8, and 9 in column 4. So all the 4 coins are accounted for. The 5s are not necessarily. Actually, we have another 5. So this is 2. We still don't know about 6. We don't know about 7. We do have another. Actually, we have 3 nines. This is a 9. This is a 9, and this is an. Okay, this 9 means this can't be 9. So this is 3. This is 9. 3 cannot be here. 3 cannot be any of these or these. Therefore, 3 must be here, which makes 1 here, which means this can't be 1, which means in box 2, 1 has to be here. I think that's all the 1s in this grid. The 3s are all in this grid done too. The 4s, 4 cannot be here. 4 has to be one of these two. This can't be 7. This remaining digits are 4, 6, 8, and 9, but obviously this can't be 4. So 4 is one of these two. This can't be 9. None of these can be 9. Where's 9? 9 has to be here, which means 9 cannot be any of these. Therefore, this is a 9 here. I think we have 3 9s, right? Which is the amount we need. So we have 3 9s. So those are done. Which means this cannot be a 9. So it has to be an 8. This has to be a 9 here, which means 9 cannot be any of these. Therefore, this can no longer be 7, because if this were a 7, this would have to have an 8 and a 9 next to it. We have a 6, 7, 8 triplet, which eliminates 6, 7, and 8 from in row 5. So this must be a 5, which means this cannot be 5. How many 5s do we have? That's the third 5, right? So this is a 5 here. This is a 5 here, and one of these 3 is a 5. And that's 3 5s that we need. So this is 3. This is done. Therefore, this cannot be 5. We have another 6. Oops. Another 6 and another 8. So that's 2 8s. This can no longer be 8. This can't be 8. This can't be 5. This can't be 9 either. So this has to be a 6. So that's another 6 there. So that's 2 6s. This can't be 6 anymore. This is 9. That forces this to be a 5, which forces this to be 4, which makes that a 5. This 4 eliminates that 4, so this must be a 4 here. This cannot be 5 anymore here. This can't be 5 anymore because we have all the 5s remaining. There's no 6 here. This can no longer be 5 or 9. This can't be 6. Where is the 5 in column 6? It has to be here. So this is 5, which means this cannot be 5. This has to be 6, 7, or 8 also. Whereas the 5 in column 5 now, it has to be here. Okay, so we've accounted for 2 6s. So one of these is 6. This is a 6. We have an 8 here and one 8 here. So that's 2 8s. This 4 means this can't be 4, so this is 2, which makes that a 4. This can't be 2, so this is 2. This cannot be 5 anymore. Where is the 5 in box 1? It has to be here. So this is 5. This is 7. One of these is 7, so this is 6 or 8 here. I don't know what happened there. So this is 5. This is 6 or 8 here. This must be greater than this. We have, well, one is a money bag. I think I have to do the boss, right? Because I think the money bags are the boss here. Would be my guess. I don't... Yeah. So let's go attack the boss, I guess. Okay, what is that? That is slash VMP 8MHUGBR. Sacrifician Lambda. You finally open the vault at the center of the temple. Inside, the frightened staff of Sudokuvania cower among the gold and riches they have hoarded. You urge them to leave while it is still safe, and they flee. The last custodian has just vanished from the temple when a safe secret passage opens to the side. You hear the confident voice of the tuxedoed man approaching from within. This is it! You are ready to confront them and stop their plans, whatever they may be. But the cultists begin chanting, and their words seem to be having an effect on the air itself. Here are the rules. Sudoku. Enter the digits from 1 through 9 into each cell without repeating in any row, column, or 3x3 box. I like that way of putting it. That's the way I feel like it fits. Digit sharing. Each cell's value for the purpose of clues is divided evenly among all clues that enter the cell. For example, if two lines intersect in a cell containing the digit 3, so say this was a 3 here, that cell has a value of 1.5 for each line. Okay, that makes sense. We have 10 lines, where all lines are 10 lines. So all the green lines, all the purple lines are all 10 lines. The colors are for disambiguation of intersections, okay? Each line can be divided by cell borders into discrete segments that each sum to 10. Digits can repeat on lines or line segments if allowed by Sudoku. Oh, that's crazy. Okay. So each cell's value for the purpose of clues is divided evenly amongst all clues that enter the cells. Okay. That means this, well, we don't know necessarily. This could be half of something, right? All lines are 10 lines. Each line can be divided, by cell borders. Each line can be divided by cell borders into discrete segments. Oh, cell borders. Okay. Yeah. That's an interesting way of putting it. I was just thinking of region sums, but it's not. It's cell borders, right? Okay, so each of these can be divided into borders with discrete segments that each sum to 10. Can be divided. Each line can be divided by cell. What does that mean? Can be divided by cell borders. That means they can be divided into discrete segments. Does that mean that you can never have a 10 then? You can't have one line by itself be into 10? No, that can't be the case because this is 3 in length. And this is never going to add up with 2 digits and 1 digit to add up to 10. So this has to be 10 by itself. This must be 10 by itself. That's interesting. So this is 10 by itself. This is 10 by itself. Any 3 line has to be that case. And these are divided by 2. This is divided by 8. And it must sum to 10. Okay. So this is divided by 2 for each of these. Therefore, this is at, if you ever have a fraction, it's only half at most. So this has to be 4 or 8, right? Because you have 1, 2, 3, 4, 5, 6, 7, 8 line segments entering in. So they must be divisible by 4 or 8 here. If this is 8, these have to be even numbers because this is only 1 in value. What are these at most? This is divided by 2, so it's 4.5 at most. If it's 4.5, the total value of these are specifically 5 here, right? At most. So this has to be at least 5. This is 6, 7, 8, 9. Can it ever be 6, 7? I guess, no. Maybe? 4, 1. Could be 9. Half, half, 9. This is 5 through 9 here. Okay. This is half and half. Is there any that's not divided by, does not have a 2 divided by it for any of these lines? I don't think so, right? This is half and half. Okay. So these could be half. This could be half. These are half. This is 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 half, and this is half. So this still could be half here. So if this is 9, this has to be 4 and 1 here, right? This is 1 half, this would be half, and this would be 9. If this is 8, 10 minus 8, this would be half. So therefore, this would be 1 and a half, and would have to be 3. So it could be 8, 3, and 4. 9, 1, 4, 8, 3, 4. If this is 7, this could be with 1. Okay, let's mark the ones that have to be half. Or could have halves, right? These 3. These 4. These 3. This one here. And this one here. This has to be even, though, also. Obviously this one too, I guess. This is half or it's 1. Okay, if this is 7, this could be half, this would be 2.5, so this would be 5. Or if this is 7, this is 8, that means this is 2 in value, so it would have to be a 4. If this is 6 in value, 6.5 means this is 3.5, which divided by 2, times 2 would be 7. If this is 6 and 8, that's 7 and this would be 6, and that's not allowed. So we have those. Similarly here, if this is 9, this could be similar, 1, 3, 4, 5, and 7. If this is 5 and this is half, this could be 9. If this is 5 and this is 8, it would have to be 8. Ah, okay. Because of this, one of these has to be odd. So therefore, this has to be 4, right? So again, if this is 9, this has to be 1 and 4. And therefore, it's always 4. If this is 9, it's 1 and 4, similar. Okay, so these work similarly, right? So if this can be 9, that could be 1, this could be 4. So then this would be half, and that would be 9. That adds up to 10. If this is 8, this has to be 4, and this has to be 3 to add up. 3 divided by 2 is 1.5. 4 divided by 8 is half. So half plus 1.5 plus 8 adds up to 10. If this is 7, if this is 8, it would have to be 4 here, right? So you have 7, 4 divided by 2 is 2, 8 divided by 8 is 1. So that adds up to 10. Or you could have 7 here, 4 here. That is 4 divided by 8, which is half. And then this would have to be 2.5, which is 5 divided by 2. If this is 6, and this is 8, that would mean this is 6, this would have to be 8. So again, okay, let's go through other possibilities. Again, if this is 9, this has to be 4 divided by 8, which is half, and 1 divided by 2, which is half. So that would add up to 10. If this is 8, this becomes 4, and this has to be, so that's 4 divided by 8, which is half, and then you have 3 divided by 2, which is 1.5. 1.5 plus half plus 8 is 10. If this is 7, this could be 8, and therefore that would be 7 with 8 divided by 8, which is 1. This would have to be 4 divided by 2, which is 2. Or this could be 7, and this is 4 divided by 8, which is half. Therefore, this is 2.5, which means it's 5 divided by 2. If this is 6, now this is the only one remaining, because you cannot have 5 here. If you had 4 here, this is divided by 2. This is at most 8, which is 1, and 9 divided by 2, which is 4.5, which would be 9.5 total, which is not allowed. So this has to be 6 at least. If this is 6, and we had this be 8, that's 6 with 8 divided plus 8 divided by 8, which is 1. Therefore, this would leave, that's 7 total. 10 minus 7 is 3, but then this would have to be 3 times 2, which is 6, and we already have a 6 in the column. So it cannot be 6, 8, and 6. It has to be 6, 4. So this is 6, and this is 4. So that would be 6 plus 4 divided by 8, which is half. So that would leave this as 3.5, because 6.5, 10 minus 6.5 is 3.5. Therefore, this would be 7 divided by 2, which is 3.5. And so these transfer all the way for this one, right? Now, this also has an additional 5. But if we try to have 5 plus 8 here, this is 5 plus 8 divided by 8 is 1. So 5 plus 1 is 6. 10 minus 6 is 4. This would have to be multiplied by 2, but then this would have to be 8 and 8, which is not allowed. So therefore, one of these specifically has to be odd. And because we know one of these has to be odd, this must be a 4. Because one of these is going to be half, and then you have a whole number with a half and a half. You have to have a half and a half added up. Because one of these is not even. One of these has to be odd, right? Because if we tried 5 and 8 again, 8 divided by 8 is 1. 5 plus 1 is 6. 10 minus 6 is 4, but you have to multiply this by 2. So that'd be 4 times 2. This is 8. You would have an 8 here also, and that'd be not allowed by Sudoku. So if this is 5, this could be 4. That would be 4 divided by 8, which is half. 10 minus 5 minus half is 4.5. Times 2 would be 9. So one of these has to be, at least has to be odd. Since one of these is odd, they both have to be odd because this is a 4. So this cannot be 4. This is an odd, this is a half digit. So we have a half. Each of these, so anything that goes out of it has to have a half in it. So this has to be an odd digit. So this is essentially, so any 4 length digit, you have to have a half involved. And you can, that half can never essentially be more than 4.5. So you have to have 3 digits at least for every line to add up to 10. So if it's 4 in every line, that means you always have to have, okay, so this has to be half. So it's 1, 3, 5, 7, 9, but it can't be 3. So it's 1, 5, 7, 9 here. Same here. This has to be half. This has to be divided by 2 and giving you a half because we already have a half here. So this must be 1, 7, or 9. Either of these can be the halves here. Either of these can be the halves here. Either of these two can be the halves. Excuse me. So this cannot contain a 9. Either of these can be the halves. So this has to be a half. Therefore, okay. The question is, okay, so what is this half adding up to add up to 10? It has to have another half somewhere else. And it cannot be here. Because if it were here, this would have to be specifically 1/2 plus 1/2, and then 2, 3, and 4. But this can never be 1 because of that 1. So it cannot match with this one. This one specifically then has to match with this one. So here we have 1, 5, 7, 9. These two adds up to so this adds up to at least 1 plus 5 divided by 2. So this is a half, which means this must be an even number. Because this is a half, this is a half. Therefore, one of these must be, these must be whole numbers. So this must be even. This is at minimum, again, 1 plus 5 divided by 2. So that's 6 divided by 2. That's 3. Therefore, this must add up to 7 at most. So it's 1, 2, 3, and maybe 4. It could add another digit here. Or it could be 1, 7 here. Either way, we know this has to be a 1, 2. And it could be with 3 or 4. This can no longer be 9. And this can no longer be 9 here. We know one of these has to be a 1, right? Because it can be at most 1, 7 here, right? To add up to 10. Because it could be 1, 2, 3 plus 1, 7, or 1, 5 with 1, 2, 4, or 1, 5 with 1, 2, 3, and 1. Actually, that doesn't work. So this has to be essentially one set. It has, because this can't be a 1, essentially. So this has to be either 1, 5 with 1, 2, 1, 2, 4, or 1, 7 with 1, 2, 3. If we tried to have 1, 5, 1, 5 with 1, 2, 3, and 1 here, that doesn't work. So this is odd. This is odd. These have to be whole numbers, so therefore this is half. We don't know about this. This cannot be 9 because it's 4 digits adding up. This can't be 1. So this is at least 2 here. What does that mean? This is 2. So these 4 digits add up to 10, but this is half, and this could be half. So that's 1 plus 3, so this is 7 at most. You could technically have a 1 here. So this is 1 at most. So 1 plus 1, that means this is 2, 4, 6, 7, 8 here. This is not half. That's interesting. So since this is not half, this is a half, and it has to be half with this at least. This is 1, 3, 7, or 9. So this is a half. We're guaranteed that has to be a half because you can't add up a 10 with this. This has to be even because this is a half. This is a half at least. So if that were a half, there's no other half to add up to it to add up to a whole number. So this has to be a whole number. Which means this has to have a half somewhere. This is at minimum 1 and 3. So this is 2 at least, which makes this have to be a 1. So it's 1. It cannot be 2. This is at minimum 1, 3, and 4 here. Right? Because you can't have a 2 there. This is 1, 3, and 4. Therefore, this is 8, and this is at minimum half and 1.5. So this then has to be 1. This has to be 3. And this is a set. So this adds up to a 10. This is a set then. That adds up to 10. It could be 2 and 9. So this is 2 divided by 2 plus 9. So that's 1 plus 9. It could be 4, which divided by 2, which is 2 and 8. 6 divided by 2, which is 6 and 7. 8 divided by 2, which is 4 and 6 here. So that's a set of 10. This is 3.5. This then, so this is a half. We have a half here. If this were a half, that would have to be another half, but that's a whole digit. This has to be 5, 6, 7, 8, and 9 as possibilities. This is a 1, 3, 4 pair. This is 5, 6, 7, 8, 9. This is then 6, 7, 8, 9 for the remaining digits. This then has to be an even digit. 2, 4, it cannot be 4, so it's 2, 6, or 8. So this is half. This is 1.5. That's 2. So this can never be 9. Can it be 8? No, because this is 2, and this has to be at least 1. So this is... So we have 2 here. This is half, and this is 4 divided by 8, which is half. This is 3 divided by 2, which is 1.5. That's 2. If this is 7, this would have to be 2. If this is 6, so that's 10 minus 2, minus 6, which would be 4, so that can't be. So this is 5 or 7. If this is 7, this has to be 2. If this is 5, this has to be 6. Right? Because this is 6 divided by 2, which is 3, plus 5, plus 1.5, plus half adds up to 10. Okay. We don't know how many these are, so... it could be 2, could be 3, we're not sure. these have to be at least 2. But we're not sure how many. Guess we can make this green. One of these 2 has to be a half. And since one of these 2 has to be a half, where is the half countering it? It cannot both be a half, right? If these are both half, then this never adds up to a whole digit, because this is a whole number, this is a whole number, this has to be half. Only one of these can be halves. So since one of these has to be a half, where is the only half you can have? It has to be here. So this has to be 3, 5, 7, 9. This is a half, this is a half. These 2 digits by themselves can never add up to 10 because this is divided by 2. So this is at most 4.5 here. But since since these cannot add up to 10, these require each other to add up to 10. And this is part of this at least. So this 5 cell line has to be adding up to 10. Therefore, this must be an even digit because this is a half, this is a half. And if we had this add up to a half, there's no corresponding half to make this a whole number. So this is 2, 4, 6, or 8 here. Okay. This adds up to 10 here, because again, you have the half and the half. So one of these 2 is a half. We're not sure which. Oh, these 3 must add up to 10. Well, this is at... Okay, so if this were 2, that makes us 1. And this would... So these 3 have to add up to 20, essentially. Right? Because it has to... They're all divided by 2. Right. So they're all divided by 2. They have to add up to 20. If we have a 2 here, that doesn't work. Because 2, 7, and 9 at most adds up to 18. So this has to be 6. This must add up to 20. It can't be 7 and 9. It has to be 5 and 9. Can't be 5 and 7 because that adds up to 18 only. So this has to specifically be 5 and 9 here. This 6, so this is half, 4 divided by 8. 6 divided by 2. So we have half, 3.5. 3 divided by 2 is 1.5. Therefore, this is 5. So this cannot be 5 here. This is half, 4 divided by 8. 9 divided by 2 is 4.5. Therefore, this is 5 here. This is 5, which means this can't be 3 or 5 because of this 3 or 5. This is 7 or 9. This can't be 5 or 6 because of this 5 or 6. This is 9. This can't be none of these can be 6. So that would be 6 plus 8 divided by 2. So this can't be 6, which means this can't be 8. If this is 6 here, that's 6 divided by 2 with 7. So that doesn't work. So this is 2 or 4. This is 8 or 9. Let's see. This is half. 4 divided by 8. 5 divided by 2 is 2.5. So that's 3, which makes this a 7. So this is a 7, which means this cannot be 7 here. Okay. Oh. This can't be the half. If this were the half, okay, so yeah, I thought these lines connected, but they don't. So if this were the half, it doesn't form a set of 10. Okay, so this has to be distinct from these. These must add up to 10 also. Because the minimum here is 2, 3, 3, 4, 5 plus, yeah, I don't even know what would work. 2, 3, if we try to have this add up to 10, this is divided by 2. but it could only be 2 divided by 2, which is 1 plus 3, 4, 5, which would be 13. It could be 4 divided by 2, which is 2, plus 2, 3, 5, which is 10. Or 6 divided by 2, which is 3, plus 2, 3, 4, which is 12. So this has to be a separate 10. This has to be a separate 10. This must be an even number, so it's 2, 6, or 8 here. So this must be an odd digit. So we have an odd. This is 1 and 3. 1, 3, 5, 7. We're not sure which, though. This is an even digit. This is half. This is at least 3.5. 7 divided by 2 is 3.5. And because of that, these two cannot be part of this one. It could be just 2. It could be all 3 digits here. We're not sure which. Actually, let's make this red. And this, we're going to make orange. So if this is 2, that makes this 2 divided by 2, which is 1 plus 9. If this is 6, that's 6 divided by 2, which is 3. 10 minus 3 is 7. 8 divided by 2 is 4. 10 minus 4 is 6. Okay. This could be essentially a 10 set here and a 10. Oh, this can't be 10. If these are 2 digits adding up to 10, it would be the same as these 2 digits. So this has to be a set of 5 adding up to 10, because these two must include this one. Because these two by themselves cannot add up to 10, because then these 2 digits would be the same. So this is a set that adds up to, this is 5 digits adding up to 10. This is 5 digits adding up to 10. That's interesting. Okay. So this is at least 4 here, right? This is 3.5 and this is half. So this is at least 4. If you have a 7 here, that would make that already add up to 11, and that's not allowed. Because again, these at most add up to 5 here. 5.5, but yeah. So this has to be part of with this one, but then this is a half. And then this can't be by itself here, these two. So these 3 must be included. These 3 must be included in the same set, so that all 5 of them are the same set. Same here. This has to be all 5, because this cannot be 2, because it's forced to be 2 separate ones here, because you can't have 4 being the same here. So this is at most 1, 2, or 3. This is 2 or 4. Again, this is half. This is at most 7.5. What's the least this could be? 1 divided by 2 plus 4 divided by 8. So that's 1 plus 1. This is at most 8. It could be 1, 2, 3. It could be 7 or 8. Well, can it be 7 really? Yes. No. This can't be 5. Oh, that's interesting. If this were 7, this would be half, 1 half. So that'd be 8, and this would be 4 divided by 2, which is possible. Okay. So the rest of this is 1, 2, 3, 7, 8. This can't be 7 here. So this can't be 7, because if that's 7, all of these would have to add up. This would be 7 plus 4 divided by 8, which is 1 half. 7.5 plus 3.5, which is already 12, which is not allowed. So 7 has to be one of these 3, which means this cannot be 7. So it cannot be paired with the 6 here. These add up to 10. It cannot be 1, 9. Cannot be 2, 8, because that would eliminate all possibilities for this cell. It could be 3, 7, as long as this is 3 and this is 7. It could be 4, 6. That's all we have. One of these is 7. That's interesting. Can this be 7? If this is 1... remaining digits in column 5 have to be 1, 2, 3, 6, 7, 8. But this can't be 1 or 2. So this is 3, 6, 7, 8. This can't be 1, 2, 3, 6, 7, 8. This can't be 1, 2, 3, 6, 7, 8. This can't be 2, 1, 3, 6, 7, 8 here. Okay. Can this ever be 8? Yeah, half, half, and 1. That certainly fits. What about here? Can this ever be 8? No. Because you could have half, half, that's 1. This is 2 divided by 2, which is 1. But that requires another digit here. So that 8 plus 1 is 10 already, and this is another digit. So this can never be 8 here, which means 8 has to be one of these two. That's interesting. So if this is 8, if this were 8, this would be half, this would be half. So, and this would have to be 1, but we would have a 1 and a 1 here in the same box, so that's not allowed. So this can never be 8, whereas the 8 in box 5, it has to be here, which means this is 8 already, this is half, 8 and a half, this has to add up to 1 and a half. So, and that's the minimum. Sorry, that is the minimum for these two digits. So this is 1, this is 2. This has to be 9 to add up to 10. So this is 2 divided by 2, plus, so just 1 plus 9 adds up to 10. These already add up to 10. This cannot be 2. This can't be 1 or 2, so it has to be the 3 or 4, which forces this to be a 1-2 pair. That eliminates 1 in the rest of the box, and 2. So 2 cannot be here, 2 cannot be here, 2 has to be here. So this is 2, this is a 1. So this is half plus another half. 4 divided by 8 is half. So that's 1 plus 2 is 3. 10 minus 3 is 7. So this is 7. This can't be 7. We have a 1, 2, 3 triplet in row 6, which eliminates 1, 2, and 3 in the rest of the row. This can't be 3 then. This is a 4. So this adds up to 1, 2, and 4. So that adds up to 7. With half, this must be 2.5. So this is 5. This can no longer be 9 here. This can't be 4. 1, 2, 3, 5, or 9. So this is 6, 7, 8 here. One of these two must be a 4 here. So where is the 4 in column 2? Can't be here because of the 1, 3, 4 triplet. Can't be here because of the 4 here. It must be one of these two. Therefore, this can never be 4. Since this can never be 4, this can never be 6 because those two must add up to 10. This is 2.5. This is half. 5 divided by 2 is 2.5. 4 divided by 8 is half. So that's 3. Therefore, these two digits must add up to 7. So this is either 1, 6, it could be 2, 5, but that doesn't work because we already have a 5 there. So this cannot be 2, or it's 3, 4. Right? 1, 6 adds up to 7. 3, 4 adds up to 7. We can't have a 2 and 5. Excuse me. This can't be 4 because of this 4. Therefore, this cannot be 4 and 6 here to add up to 10 because that would eliminate all possibilities for this cell. So this must be 3 and 7. That makes this a 4, which means this can't be 4. This is 6, and this must be 1. Because you have 5.5. 5 divided by 2, which is 2.5, plus 4 divided by 8, which is half. So that's 3. These must add up to 7. This is 6. This is 1. We have an 8, 9 here, an 8, 9 here. This can't be 7. This can't be 7. This can't be 3. This can't be 8. This can't be 8. None of these can be 8 because of this 8. These can't be 1. Three and 7. 1. Okay, so one of these must be an 8 or 9. This is an 8 or 9. Therefore, the rest... Okay, so 3 has to be one of these two. The remaining digits in row 4 are 1, 3, 4, and 8. This can't be 1, though, because of that 1. This can't be 4. We have a 3, 6, 7, 8 quadruplet in box 4, which eliminates 3, 6, 7, 8 from the rest of the box. Therefore, this can only be 5. This 6 means this can't be 6, so this is 7. This can't be 7. None of these can be 7. This can't be 1, because this is a 1. We have a 3, 6, 3, 6 pair in row 5, which eliminates 3 and 6 from the rest of the row. Therefore, this is 2. The remaining digits here are 1, 3, 4, and 8. This can't be 1, though, because of that 1. This can't be 3 because of that 3. One of these is 8 or 9, because either this is 9 with 2 or this is 6 with 8. This can't be 1. Therefore, the rest of row 9 cannot contain an 8 or 9, so that leaves 2, no 3, 4, 5, 6, no 7, no 8, and 9. This can't be 2. This can't be 6 because of that 6. This can't be 5. Let's see, what else do we have? This is half. This is at least... So this is, okay, so this is at least 7 divided by 2, which is 3.5. So this is 4 at least. 5. So 4 for these two, plus 8 divided by 2, which would be 4. 4 plus 4 is 8. This is 9. This would have to be a 1, but that's not allowed. So this can never be 8. These digits are 6, 7, 8, and 9 remaining. Okay. So can these 3 digits ever add up to 10? No. And you can't have 4 because this is a half, so it would have to be 5 effectively, which doesn't work. So these have to be 2 adding up to 10, because these 3 can never add up to 10, and these 5 can never add up to 10. Because this is already greater than 10, 2, 3, and 6. So this has to be add up to 10 here. This has to be at least a separate thing. We'll make that pink. So this is separate, and this could add up by itself. Or it could be part of this set of 5. This is at least 4. So since this is at least 4, these already have to add up to 10. This is 6. This must be then 7 and 1. Adding up to... This 1 eliminates this 1, so this is 2, this is 1. These are a set. This has to be a separate set also. So it's 2 divided by 2, which is 1, and 9. But it can't be 9 here, so this can't be 2. 4 divided by 2, which is 2, and 8. That's possible. 6 divided by 2, which is 3, and 7. That's possible too. So these are a separate set. This is already 4, right? Right, because that's 4 divided by 8, which is half. 7 divided by 2, which is 3.5. So that's 4. This is 1, 5. You could have 2 with a 6, or 3 with a 4. So this can't, okay, so this can't be 6, this can't be 6, this can't be 6. This is 3, which makes this a 6, which makes that an 8, which makes that a 3. None of these, this can't be 8, this can't be 8, this can't be 3, these can't be 8. We have a 7, 9 pair here. This 7 eliminates that 7, so this is 9, which makes that a 7. This 7 and 9 eliminates 7 and 9 here, so this is 6, 8. We have a 6, 8, 6, 8 pair. This 8 means this can't be 8, so this is 6, which makes that an 8. These can no longer be 6 or 8. This can't be 6 or 8. We have a 7 here, which eliminates 7 here, so this is 9. This is 7. This 9 eliminates that 9, so this is 8, which makes that a 9. This can't be 9 anymore. This must be 6. And 6 must add up with 8 divided by 2 to add up to 4. So this can no longer be 6. This can no longer be 6. This 8 means this can't be 8, so this must be a 7. This 1 eliminates 1 from being here. Therefore, where's the 1 in row 2? It has to be here. That leaves this as an 8. This has to be 4. This is 8 divided by 2, and we have half and a 4 divided by 8. So I think that means it's 2 and 3, right? 8 divided by 2 is 4. Half and half adds up to 1. So 4 plus 1 is 5. 10 minus 5 is 5. So this has to be a 2, 3 pair to add up to 5. Therefore, we have 6 and 9 remaining, but this can't be 6 because of these 6's. So this must be 9, which makes this a 6. These add up to 10. So it must be 7 with 6 here, which makes this, whoops. This is 6. Divided by 2 is 3. This is 3.5. 7 divided by 2. So actually just add up these. So this is 4. No, actually that doesn't work. 13 divided by 2, which is 6.5, plus half, which is 7. So this is 1, and this must be 2, which makes this 3, which makes that a 2. This can no longer be 2. This is a 4, 5, 4, 5 pair, which eliminates 4 and 5 from the rest of the row. So this must be 2. This is a 1, 4 pair here, but this can't be 4 because of this 4, so this must be 1, which makes this a 4, which makes that a 1. Okay, and this looks like it's just Sudoku now. So we have all the 1s accounted for. Do we have all the 2s? We have 8 of the 2s, so we know where the last 2 has to be. It has to be here. 3s. 3 in box 8 has to be one of these 2 cells. So it cannot be here. Therefore, this is 4. This is 3. We have now 3 can be here or here. We don't know which. 4s. 4 in box 8 cannot be here because of this 4, so it must be here. So this is 4, which makes that a 5. We could have 4 here or 4 here, so that's not known right now. 5, we have in box 2, where's the 5? It has to be here. So this is 5. We have 8, 5 now. We know where the last 5 has to be. It has to be here. 6s. 6s in... We have 8 6s. We know where the last 6 has to be. It has to be here. 7s. We have 8 7s. We know where the last 7 has to be. It has to be here. 8 8s. Do we have 8 8s? No, but we know where 8 has to be in box 2. Can't be here. It must be here. So now we have 8 8s. We know where the last 8 has to be. It has to be here. And then 9s. We know where the 9 has to be in box 2, which means we know where the 9 has to be in box 3, which means we know where the 9... We have 8 9s now. We know where that 9 has to be in box 9. So it's there. And I think it's, what, 3s and 4s remaining. 3s cannot be here, therefore this must be 3. And this is the last 3. Then we have 4s. 4 can only be here and then here. The last of the cultists flees. There is no sign of the man in the tuxedo anywhere. You have defeated the cultists and solved every boss puzzle. You can leave with the castle's treasure if you wish. Their plans probably weren't already set in motion, right? Enter 6 into this puzzle's boss cell in Sudokuvania. Okay, we are not there yet because we didn't see the boss, I guess. There's no boss cell that I saw in the Golden Throne. Hmm. Right? Either that or I'm missing a coin, right? I don't see the boss in the Golden Temple. So we've solved for that. That's 6. But we haven't found where that is. Okay, so we're missing a coin somewhere? We must be missing a coin. I don't know where, though. Okay. There's a coin here. There's a coin here. No coin, no coin, no coin, no coin, no coin. No coin, there's a coin here, right? So that's 3 coins in grid 1. In grid 2, no coin here. No coin here. No coin here. No coin here. There's a coin here, 9. Coin here, 5. Coin here, 8. No coin here. There's no coin here. So that's 3 coins in grid 2. Grid 3, no coin here. Coin in grid 8. Coin at 8 here. No coin here. Coin in grid 4 for 4 here. That's no coin here. No coin here. No coin here. There's a coin for grid for number 9 here. And then no coin here. 4. Grid 4, we have a coin for 7 here, 9 here, no coin here, no coin here. There's a coin for 8, no coin here, no coin here, no coin here, no coin here. So that's 4. This is the library. Okay, my navigation's getting better, at least. This is not a coin. We have a 6 here. Nothing else. Nothing else. Nothing else. 9 here. An 8 here. Nothing else. Nothing else. Then we have the mate. Oh, that's grid 6. This was grid 5, right? So then grid 6. We have an 8 here. We have a battery. Does the battery count as anything? I don't think so, right? There's no coin here. No coin here. There's a 6 here. No coin here. No coin here. No coin here. No coin here. And there's a 7 here. So 6, 7, and 8. So that's 3 coins in each grid so far. Grid 7, elsewhere. Okay. Looks like there's 3 coins here. This is 9, blank, blank, 5, blank, 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 7, blank. Are there any coins outside the grid? Not that I can see. So we have 1, 2, 3, 1, 2, 3. Only 2 in grid 3? Okay, maybe that's where we messed up. Okay, so we have 3 and 4, 3 and 5, 3 and 6, 3 and 7. And these are the ones that have to be a 9, essentially. And we translated there. So that there's only 2 in grid 3. I don't think that's correct. Right, we had a 4, 8, and 9 in grid 3. So we missed one. Okay, there we go. So that's what we missed. Okay, so there's a 4, 8, and 9. There's 3 coins in each grid, so we missed a 4, 8, and 9 here. This is 1. So this must add, this then has to be 3. We have 3 left over. Okay, so that's what we messed up. Again, I knew I was going to run into that issue. So we didn't keep track of it correctly. Okay. Therefore, that updates that. This is 5 here instead of 4. So that makes sense. And therefore, this is 3 left over. Okay, so we have all the coins then. Let's go from here. Okay, that's not good. No, don't want there. How about here? Okay, so we have 3 6s. Okay, so we have a 6 8 pair here, which is already taken care of. 1 8, 1 6. So that's 2 for 6 and 2 for 8. We need 3 7s. One of these is 7 or 8. One of these is 6, 7, or 8. This... Okay, we have 2 6s again. We need 3 7s left, right? Because we do not have enough 7s. Okay. So one of these must be a 7. This one must be a 7, and this must be a 7. Because we need 3 of them left. So one of these is a 7. Well, we're guaranteed one of these is a 7. We need 2 more. If this is a 7, that would not work. So this is 6 or 8. This has to be a 7 then, which makes this an 8, which makes that a 7. 8 cannot be here or here. This 7 means this can't be 7, so this is an 8, which means this can't be 8. This 7 means this can't be 7, so this is 6, which makes that an 8. This can't be 7 or 8. This can't be 7 or 8. So we have all 3 8s now, because this is an 8, this is an 8, and this one of these two is an 8. So that's done. We have all the 7s we have all the 7s also, and we have all the 6s. So this cannot be 8 here anymore for either of these coins. So it's a 6 7 6 7 pair, which eliminates 6 and 7 from the rest of the row. So this is 8. This cannot be 8. This cannot be 8. This can't be 8, and this can't be 6 because of the 6 there. This 6 means this can't be 6, so this is 7, which makes this a 6. Neither of these can be 6. Since this is 6, this can't be 6, so this is 7, which makes that a 6, which makes that an 8, which makes that a 6. This 8 eliminates that 8, so this is 7. This 6 eliminates that 6, so this is an 8. This 7 eliminates that 7, so this is 8. There's no 7 and 8 remaining here. This 6 eliminates that 6, so this is a 9. This can't be 6, 8, or 9, so this is 7, which makes that a 6, which makes that a 7. 6, 9, 6, 9. This cannot be 7, 8, or 9. Therefore, this is 6, which makes this a 9, which makes that an 8. This 6 eliminates that 6, so this is 9, which makes that a 6. And that's the boss. And I think he said that that was a 6, right? Yeah, enter the 6 into the boss. Okay, so we already did that. So this is a 6 then. We've got some funky thing here. Grid Z designated by door. Okay, so then we can clear all this stuff. Okay. Let's clear all of this here. And then clear the grid that we were counting our coins. So we got all the coins done. That's a lot of stuff we have to... Okay. Interesting. It doesn't mark them as done. I don't know. Solve the title. Okay, we need to increase there. Shrink. Get further, I guess. That doesn't work. Yeah, let's reload. It's gonna take a while to do that one. We're getting close to finishing, I think. Okay. Do we have a rule set? We do not, that I can see. Actually, we just reload. Just double check. There is some. There might have been something on the lower left. I don't know. Nope, there's nothing there. Okay, so let's go to here. We have grid Z, designated by door. Open the secret door to the center of the castle. Not all cells necessarily need to be filled. Okay, so this is outside, essentially, the grids. Which, since it's outside the grid, that means thermometers don't require one. I think, actually, German whisper lines don't require one either, right? Thermos can be blank. Yeah, blank cells on whisper lines are ignored. Okay. But arrows must still be fulfilled. Okay, so this is definitely... Okay. Where does this go? So these have to be filled. This is in a 1-to-2 ratio. So we have 1, 2, 3, 4, or 6, 8 as possibilities in these cells. These two, okay, that's interesting. These two can never be essentially... These two digits can never be in a... cannot have a difference of 5 or more. Right? Because these are specific. Everything that's filled in is a digit. It's never, it can be 0 through 9, even outside the grid. So, because of that, this cannot be like 5 and 10, because we need to fill it out, right? Because of that, these two also must be part of these must be filled out, because we have to... Actually, it has to... Only one of them is filled. How does the thermometer work? That's weird. I mean... Right, because... Oh, I guess. This thermometer, it doesn't... go back on it. Okay, okay. So how does the thermometer work? It goes from here to here. Okay, yeah, well, this is not going to be helpful. Okay. It, how does it go? It goes from here to here to here to here to here to here. So here, 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 here. Okay. So this is the smaller of them. This cannot be sorry. This cannot be 1. This has to be smaller than this. This can't be 8. So if this is 1 and 2, okay, right. If this is 1 and 2, this has to be the smaller of it, so it's 1 and 2. If it's 2 and 4, this is a smaller, so this is 2 and 4. If this is 3 and 6, this is a smaller, 3, 6, and if it's smaller, it's 4 and 8. But the problem is it can't be, say it tried to be 4 and 8. I guess that could be the case. Yeah, that could be the case. This is always smaller than this one. So if this were essentially filled, the problem is you would need something here to be larger, which it could be. So this is small, small. This is at most 1 through 4. It has to be less than 4. So this is 1 through 3. So it goes here, 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 here. This is less than, this would be less than 4 also, if it is. 1 through 3. So here, 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 here. So this is greater than this. So this is 3 through 9. Then to here, this is 3 through 9. So it goes here to here, here to here, 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 here. So this has to be greater than this. This is 2, 3, 4, 5 to 7 because it must be smaller than here. But it goes here, 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 here to here. So this must be greater than that. This is at least 3, 4, 5, 6, 7 because it's smaller than that one. So this is smaller than here. So this, I'm sorry, this bigger than here cannot be 3. This is then more than a 2. This cannot be 1. This has to be greater than 2. This has to be greater than 3. This is 4, 5, 6. So this cannot be 4, which means this can't be 2. So this is 3 or 4, which makes this 4 or 5, which makes this 5, 6, and 7. So we have 6 or 8 here. Okay. This is 6 or 8. That has to be next to a low, but it cannot be next to specifically these 2 lows here. This has to be greater than 6. That's problematic. Oh, no, it can't be both 1s. How does that work? Because it needs to have a difference of 5, and then needs another difference of 5 between there, and then therefore it's 3, 4. But the problem is this has to be 8, which makes this 4, 4 has to be in between 9 and 9. We have a failure here. Something about my logic is incorrect. Arrows still need to be filled out. So, and 2 parts of a... You could have... Can you have a 0? You can have a 0. You can have a 0 outside the grids. Okay, so that's where I'm messing up. So I need a 0 then. Right? We have no restrictions. Yes, black dots always border 2 digits, right? So we have to have a digit there. Arrows must still sum up to the digit in the whip circle. So it has to be 0. There is no restriction on there being... So therefore, that's what it is. It has to be 6 and 3. And the 3 has to be next to 8 and 9. Okay. Right. So this has to be 6 and 3, because 4 cannot be... These are digits, remember. So this has to be a 9. This is a 3. This is an 8. So this has to be 0, and this is 1, which makes that a 6. This is 4, this is 4, this is 5, and that's 5. Oh no, another... No! We have another puzzle! Oh no! Okay. Grid 10, designated by throne... Wait, wasn't this a throne room? Oh, it's Golden Temple. This is throne room. Grid 10, designated by throne room. You have found the hidden heart of Castle Sudokuvania, and its columns are laden with some kind of arcane device. Can you deconstruct it before it activates and destroys Sudoku forever? Deconstruction. Locate 9 3x3 boxes to be placed in the 11x11 grid, and place digits from 1 to 9 into each box without repeating in a row or columns. Cells not in any region must remain empty. Okay. Do we have any additional rules? Okay, maybe we okay, so now this I think is going to be the second to last video, not the last video, because this is a whole other grid that we have to do. Okay, so this is in the 11x11 throne room. Instead of placing digits from 1 through 11 in each row and column, locate 9 3x3 non-overlapping regions and place the digits from 1 to 9 into each one. Digits still may not repeat in a row or column. Cells in this grid which aren't in any region must not contain the digits. Okay. Okay, this is going to take a while. So I think we're basically going to put it at stop here and continue on in the next video. And I think this is the last one. So hopefully that will be the last video. Anyways, we're essentially over 1,000 in 1,000 minutes in this solve. So this is taking quite a while, but considering how many puzzles we are going through, it makes sense. Okay, so if you can, okay, we can't see that. Let's take a look at what our situation is right now. We have filled all the learned rules. We have solved all the grids and all the whatchamacallits, the bosses with those grids. We have found 3 hidden puzzles. We have not solved the title. For some reason, the coins don't register. I don't know why. But we use that to solve things, so I don't know. I count that as solved. We haven't found all the sandwiches. We've got this sandwich, and this sandwich. Maybe we need to figure out what those sandwiches are related to. But I don't see it. Um, Doesn't have anything there. Wall sandwiches quest. Okay. So we do. Okay. Well, what's this? This doesn't say anything. What about this? This doesn't say anything. Okay. Let's solve this then. Hints given by the caretaker. Keep your eye open. Do we? Oh, maybe this is used to keep track of the number of digits we have. So we have all the coins now. Okay, this is supposed to probably keep track of all the coins that we had. Yeah. I should have probably used that instead. That was probably where it was. So we have that. Then we have, this is the, okay, wall sandwiches. This doesn't give us anything. Yeah, cells outside of the grid may contain a 0, or they may be blank. I still don't get why this has to be a 0, and why this one can be blank. It doesn't say anything about bulbs, right? Outside cells on thermos or arrows can be blank. Is the bulb not considered a... It's outside the grid, so it could be blank. Only one of them is 0, but it has to be that one for some reason. I don't know why. Anyways. Yeah. Anyways. Let's take a look at walls. Okay, wall sandwiches quest given by Mr. Snake. I hid some snacks in the walls of the castle in case I get hungry later. But I'm hungry now, and I can't remember the recipes. If I tell you where to find them, can you look and see what they are made of? Wall food clues next to a row or column indicate the sum of the digits between two crust digits in that row or column. Different food icons can have different crust digits. Given the food icon and sum for 3 rows/columns, enter the 2 crust digits, low and high respectively, in this panel to complete the quest. Okay. That's okay. Yeah, so that's what. Okay, so we need 17. Yeah, we're going to continue on right now to finish this side quest before we're looking for the main quest tomorrow, or the next time I do a video, which probably will be tomorrow. So we have to add up 17 between 2 digits. How many 17s do we have? 9, 1, 2, 5 adds up to 17. So it could be 8 and 3, between 8 and 3. Obviously 8 cannot be part of it. It can't be just 8 and 9 because it's between 2 digits. So it could be 3 and 8. We have 1, 2, 5, 3, 7. So between 9 and 4. So right now we have, okay, so we have, this one can be between 3 and 8. Ugh, this is so hard to see. This could be 3 and 8. This could be 4 and 9, right? Because we have, so between 3 and 8, we have, so this adds up to 17 here. Starting from 1, we have 1, 2, 5, 3. Oh, wait, no, that's 18. So 4 and 9 does not work. Starting from 2, we have 2, 5, 3, 7. So that's 1 and 4. 5. Starting from 5, that does not add up to 17. Starting from 3, that does not add up to 17. And starting from 7, that does not add up to 17. So we have 3 and 8 and 1 and 4. If we have 3 and 8, that adds up to 17. 1 and 4 does not add up to 17. So it's 3 and 8. And then we have 3 and 8, that adds up to 17. So it's 3 and 8. So we know this is 3 and this is 8. That's check. 19. Okay, we have 19 now. I don't know where the 19s are. So these are done. 19, I see one here. I see one here. There should be 3 of them, right? That's what they said. Okay, let's just look at this. Things that add up to 19. 1749 does not add up to 19 anywhere there. 749 does not add up to 19. 4928 does not add up to 19. 928 does add up to 19, so that's between 4 and 7. 287 does not. Okay, so this is between 4 and 7, right? So this should be. That's not 19. It's over here, which I can't get to. Okay. So between 4 and wait, that definitely does not add up to 19. Did I miss one? I must have missed one. 298 between 4 and 5. Oh, we have a 7 and a 7. That's problematic. Wow, that's really bad. Huh. How did we mess that up? Wow, that was pretty bad. Okay. This is not a 5. This is a 7, so this is 5. I don't know how we messed that up. That was pretty bad. This is a 7. This has to be 5. So it's between 4 and 5. Okay. So that works. This was pretty bad. This is definitely a 7 because it's a boss. So this has to be 5 then, which forces this to be 7. I don't know how I messed that up anyways. And it's just misentering. So this is 4 and 5 between here. Those were the only... okay, well, maybe we can calculate again. So 1749, does it ever have a 19 in it? 17 is 8, 174 is 12, 1749 is 21, so no. 749, 74 is 11, 749 is 20, so no. 492... 49 is 13, 492 is 15, 4928 is 23. 928 does add up to 19. 285 does not add up to 19. And it does, so it's 4 and 5, and this is 4 and 5. So this has to be 4 and 5. And now we have 9s. This must have a 9 in between. Okay, so let's clear this up. This is a 7. That was a pretty bad mess up. This is 5. So this has to be 4 and 5 here. We have 9s here. 7 and 1 is 8. 7, 1, 3 is 11. So that doesn't work. 1, 3 is 4. 1, 3, 6 is 10. So that doesn't work. 3 and 6 work. So between 1 and 9. So between 1 and 9 works. So we have 1 and 9 here. 6 with 9 does not work. That's 13. That's 15. 9 works, so between 4 and 6 also works. 9 and 4 adds 4 and 5 adds up to 9. So 2 and 9 works. So 1, 9, 4, 6, or 2, 9. So 1 and 9 has a 5, so therefore that does not work. So it's 4, 6, or 2, 9. 4 and 6 has everything, so that's not allowed. So it has to be between 2 and 9. Okay, so this is specifically 2 and 9. And we've solved that quest. So Okay, so we've solved... Okay, so the coins were just basically to keep track of the coins, which is actually makes sense. That would have made things a lot easier if I'd kept track of the coins in those things. So we have finished all the 1 through 9 coins. We have not found this hidden puzzle. I don't know what that one is. Technically, we could have a 2 somewhere here. We don't have to. We have to have 3, 4, 5, 6. We could have a 7 somewhere in these two spaces, but we don't know. None of these can be dark. Can be filled, but in this one cannot be filled. This one cannot be filled, but either of these could be 2. Either of these could be 7. We don't know which, but we don't have anything there. So I don't know if there's another hidden puzzle. There looks to be another hidden puzzle. It's here, right? But this can't be 9 here. I don't think. Because it's part of the thermometer, right? So that can't be 9, and 9 has to be one of these surrounding ones. Maybe we'll find it from solving the last grid. Anyways, that makes that set for this part of the solve for Sudokuvania. We have finally the it's not throne room. Yeah, there is another hidden puzzle, but I don't know how we can solve that technically. Yes, it is the throne room. This was the golden temple. This is the throne room. So we have to solve the throne room. And hopefully we unlock this hidden thing here, which we sort of figured because it's 7 and 2 with an arrow, but we don't know where the arrow goes, right? There has to be a 9 somewhere. So maybe we have to solve this deconstruction area, this grid 10, and that will clear out the last mini puzzle. Anyways, I'll see you next time on the solve for Sudokuvania. Take care.